In mathematics, a superparticular ratio, also called a superparticular number or epimoric ratio, is a ratio of the former n is a positive integer. Thus, a superparticular number is when a great number contains a lesser, to which it is compared, and at the same time one part of it. For example, when 3 and 2 are compared, they contain 2, plus the 3 has another 1, which is half of 2. When 3 and 4 are compared, they each contain a 3, and the 4 has another 1, which is a third part of 3. Again, when 5 and 4 are compared, they contain the number 4, and the 5 has another 1, which is the fourth part of the number 4, etc. Superparticular ratios were written about by Nicomachus in his treatise, Introduction to Arithmetic. Although these numbers have applications in modern pure mathematics, the areas of study that most frequently refer to the superparticular ratios by this name are music theory and the history of mathematics. Mathematical properties. As Euler observed, the superparticular numbers are exactly the rational numbers whose continued fraction terminates after two terms. The numbers whose continued fraction terminates in one term are the integers, while the remaining numbers, with three or more terms in their continued fractions, are superpartient. The Wallace product represents the irrational number pi in several ways as a product of superparticular ratios and their inverses. It is also possible to convert the Leibniz formula for pi into an Euler product of superparticular ratios in which each term has a prime number as its numerator and the nearest multiple of 4 as its denominator. In graph theory, superparticular numbers arise via the Erdos-Stone theorem as the possible values of the upper density of an infinite graph. Other applications. In the study of harmony, many musical intervals can be expressed as a superparticular ratio. Indeed, whether a ratio was superparticular was the most important criterion in Ptolemy's formulation of musical harmony. In this application, Stormer's theorem can be used to list all possible superparticular numbers for a given limit, that is, all ratios of this type in which both the numerator and denominator are smooth numbers. These ratios are also important in visual harmony. Aspect ratios of 4:3 and 3:2 are common in digital photography, and aspect ratios of 7:6 and 5:4 are used in medium format and large format photography respectively. Ratio names and related intervals. Every pair of adjacent positive integers represent a superparticular ratio, and similarly every pair of adjacent harmonics in the harmonics series represent a superparticular ratio. Many individual superparticular ratios have their own names, either in historical mathematics or in music theory. These include the following. The root of some of these terms comes from Latin sesqua, 1.5, describing the ratio 3:2.